Hi, this is Mr. Joel Tan, and this is the first of two videos for variable weather and changing climates. Gateway 1 is on variable weather, and Gateway 2 is on changing climates. Before we begin, I would like to highlight to you this website. This is the SEAB website, where you can get all your syllabus documents for all your subjects. I highly encourage you to open it up, and while you're studying, refer to it. Let me now go to the Social Studies and Geography exam syllabus. Over here, I have the geography syllabus moved all the way to topic 2, variable weather and changing climates. So for this video, I'll be focusing on key question 1, why do different places experience different weather and climates? As you can see, there's learning outcomes, there's the content that's required, and all the main terms. At the end of your revision, you should be able to explain all the different terms over here and to be able to come out with definitions, diagrams, and explanations of all these things that's over here, the middle portion. So let's begin. In this first part, you're supposed to know how to define what's weather and define what's climate. Understand that there are different elements of weather, which is temperature, humidity, clouds, rainfall, pressure, and winds. So let's look at that. We have gone through this, that the difference between weather and climate is that the weather is the condition of the atmosphere at a particular place and time, whereas climate is the average condition over a long period of time, usually over 30 years. So as we have known, these are the different weather elements: temperature, clouds, rainfall, relative humidity, pressure, and winds. Now let's look at temperature. What are the factors that affect it, how to measure it, and what is the unit of measure? So in this case here, temperature is measured in degrees Celsius, usually by an analog or digital thermometer, and you could also use a maximum or minimum thermometer to measure the maximum and minimum temperatures. Well, we know that the factors affecting temperature include latitude, altitude, distance from sea, and cloud cover, as mentioned in the syllabus document here too. As you can tell, in this part here, there will be these few particular main terms that needs to appear in your answer to explain about the different factors. Let's begin. As we know, latitude is affected by the temperature is affected by latitude because of this. When if you are nearer the equator or you have 0 degrees of latitude, the area is shorter distance from the sun, and there is a smaller surface area. The sun rays are hitting a smaller surface area. However, if you are on a higher latitude, the sun rays hit a larger surface area over here, and you also have a further distance from the sun. So remember that we need a diagram, a box, a title, this diagram here, the sun rays, and the triangle to show the larger surface area and the small surface area. And the second part would be the distance from the sun. You can also talk about the solar angle being higher nearer the equator, and solar angle being smaller further away from the equator. The second factor is actually altitude. The further you are away from the Earth's surface, the temperature drops. And this is because you are moving away from the ground, which is radiating heat. The third factor is distance from the sea, which we have here as the maritime effect. In summer, the sun is up, and because the sea is a poor conductor of heat compared to the land will heat up faster, and hence the area above the land is warmer, right? Whereas the sea, which is water, heats up slower, hence the area above the sea is cooler. Hence there is a difference in air temperature if you are nearer or further away from the sea. That's the same for winter, right? In winter, the land cools down faster and the sea cools down slower. Hence, the air above the sea is warmer, whereas the land above the land is cooler, right? And because of that, we will see that inland will have warmer summers and colder winters due to the fact that land heats up and cools down faster, they will have a larger annual temperature range. Remember, this is within a year. So some months they will have warmer summers, other months they have colder winters. So in this case here, there's a large annual temperature range. And the same for coastal, which is near the sea. They have colder summers and warmer winters, so they have smaller annual temperature range. Fourth factor that affects temperature is actually cloud cover. When there's clouds and when there's no clouds, in the day, the sun rays are being reflected and absorbed away from the sun, away from the ground. Beg your pardon, and hence it is cooler. Whereas when there's no sun, the sun goes down direct, it is warmer. The opposite is true in the nights when with clouds, the heat from the ground gets reflected back in, hence it's warmer. But when there is no clouds, it gets radiated from the ground to space and hence it's cooler. Now when we look at this will cause a smaller daily temperature range. Diurnal means daily when there is a cloud, and a larger temperature range when there is no clouds, as you can see from this table here. Next weather element we're going through is relative humidity. Relative humidity is the proportion of water vapor present in the air when there is in proportion to the maximum amount of the air can hold at a particular temperature. Saturation point is when the air carries the maximum amount of water vapor, which means it's 100%. Let's look at this diagram. When air is heated up, the air expands and hence there is more space. However, water vapor amount remains the same. So as you can see, with temperature increases, relative humidity decreases. What kind of relationship is this? Inverse relationship. Okay. Remember what instruments are used to measure relative humidity? We did that for GI. Now, when there is high relative humidity, it indicates that rain is likely to occur. Because there is a lot of water vapor in the air, it will form clouds and hence there's higher rain. And this also results in thicker vegetation in that area, okay? And the opposite is true for deserts. So this is the relationship, as you can tell. As you are describing a graph, if we ask you to describe the trend, remember that you need to code the data. So in this graph, this is not really very good, but there should have numbers at the sides. And you should tell me 12 a.m. to 6 a.m. the relative humidity increased from here to here, temperature decreased from here to here. Okay, and you could tell me the meeting point is over here. Next weather element we're going to talk about is clouds. Basically, I just need you to remember that cumulonimbus clouds are the clouds that we usually see in Singapore, and these are the clouds that usually causes rain. Okay, so that's about it. You can remember all the other clouds. This stratus, cumulus, and cumulonimbus are the major ones that you need to know in your syllabus. We could also do this activity if you want. You could do it as a side project before your exam. Next weather element is rainfall. Now we know that precipitation can come in many forms, and we are talking about the form of rain. In this case here, we need to learn two diagrams, which is relief rain and convectional rain. Now relief rain, remember, it comes from the sea, okay? Air from the sea carries large amounts of water vapor. As warm, moist air is blown towards the mountain range, it goes up. The air is forced to rise, it cools, and it condenses. Okay? Before it actually reaches the other side of the mountain, it reaches its dew point temperature and it condenses. Clouds are formed, and when the water droplets, I beg your pardon, are large enough, they will fall on the windward side. And by the time they reach the leeward side, the air is dry and then there is no more rain. The other kind of rainfall is called convectional rain, which is often seen in tropical areas like Singapore. It has intense rainfall that lasts for short periods of time. This happens when the sun's energy heats up the Earth's surface intensely. The area around the surrounding air is heated up in the process and it gets heated very hot. The surrounding air expands and rises. As it rises, the temperature begins to drop, cools to dew point temperature over time. Condensation is formed, clouds are formed, cumulonimbus. If the clouds become large and heavy, it accumulates water vapor, water droplets fall to the earth as rain. This often comes with thunder and lightning. This diagram is not really accurate because we want to see all the three stages in the same diagram. I've gone through this in class, and you could also refer to your textbook for this example. Remember the diagram needs labels, titles, and explanation. Now let's look at the last element, which is pressure and winds. Now remember that as we go up the mountain, pressure decreases because gravity pulls all the air molecules down, right? So basically when altitude increases or as the height increases, air pressure decreases. And remember this diagram here, this is how you read the diagram. You must code some data, right? Now, why is there moving air? It's when an area of high pressure pushes the molecules to an area of low pressure because there is more space at the other side, right? And so that's that. So it causes wind, and in this case here, let's look at a localized wind system, which means it's only happening in one area, and we usually see this as sea breeze or land breeze. So firstly, let's look at sea breeze. The sun heats up the land and the sea. We mentioned it just now. And because the land heats up faster, hot air rises. When hot air rises, the pressure is low because it is rising against gravity. Whereas at the sea, it's cold because it is a poor conductor of heat. So there is high pressure. So in this case here, because of the high-low pressure, wind blows inland and it is a sea breeze. Now let's look at the night. The converse is true. Okay, it cools down faster on the land and cools down slower in the sea. So there is high pressure here, low pressure here. The wind blows from the land, it becomes a land breeze. So that's that. Okay, as you can tell, this is the localized wind. Let's look at the regional winds. Now, as the Earth rotates this direction, okay, you will think that winds can go straight. However, due to the rotation of the Earth, right, winds over here will turn to the right because this person is walking downwards, and you can see that the wind blows to the right. If it's blowing from the south pole to the equator, okay, it will push the other direction, which means that it's pushed to the left. So how does this affect? This effect is actually called the Coriolis effect and causes wind to change direction. So how does that affect regional winds? For example, in the northeast monsoon, in October to February, China is having winter, whereas Australia is having summer. So there is low temperatures in China and high temperatures in Australia. With that, during summer when hot air rises, right, there will be an area of low pressure. In winter, cold air sinks, so there will be an area of high pressure. Because there's a high pressure and a low pressure, there's a difference in pressure. Winds go from the north to the south. But because of the Coriolis effect, winds will have to travel not in a straight line, but it will turn to the right first before turning to the left, in this case in the northeast monsoon. So the next video we'll continue with the southwest monsoon, and then we'll end off with climate.